technical resource for all the clouds, especially this time for the Oracle Cloud.
And my name is Jeff Engel. I'm the Cloud Alliance Architect at Checkpoint. As you can see on the screen, I am a global resource for anything Oracle inside Checkpoint, and looking forward to helping everybody out today and just kind of set the tone. We want to make this as non-marketing as possible. We want to make it a very technical engagement. So feel free to reach out and ask any questions as we go. Slow us down if we're going too fast. And we'll make it super informal. We're not going to bore you with slides. So appreciate your time, and let's get cracking.
Sounds good. So as Jeff mentioned, like we'll go over just a workshop outline first. So the idea was like the intention is to get yourself familiar with Oracle Cloud Infrastructure, as well as how you can use the Checkpoint CloudGuard solution to make sure that you can secure your workload running on your Oracle Cloud Infrastructure premises. So the idea is like we created a workshop, and the workshop has some outline. So the outline, as you say in the left-hand side, ideally you can deploy the workshop using Oracle Resource Manager, or if you choose to, you can always deploy that manually also. So manually allows you to have hands-on experience on different aspects like network, subnet, instances, security policies, CloudGuard checkpoint solution, listings, and all. But we have also automated that we will show in the workshop, so you can follow that also. And intention is we're going to use the Checkpoint CloudGuard firewall using the marketplace. So as you know, OCI marketplace allows you to expose and consume a Checkpoint solution. So that's what we're going to do there. And then we're going to jump on the CloudGuard firewall configuration, like what are the required configuration which you need to do to support that CloudGuard, as well as security on OCI. Then in the end, like we will do validate our traffic. So in the way, like we'll do the north, south, east, west. We will also do the high availability to support the traffic. So to support this workshop, these are some prerequisites which needs to be happen. So for example, as I mentioned, we're gonna consume CloudGuard solution of security gateway. We're gonna do CloudGuard deployment in high availability, like active passive use case. But to support that, you would have to have access to bring your own license, at least bring your own license listing on marketplace. So if you are not familiar with an OCI, like if you are joining the first time, an OCI, you can create a free tier account, but free tier account doesn't expose the marketplace listing. So as Jeff already sent an email before the workshop, you have to ensure that you have access to marketplace listing and as well as like a paid tenancy. And there are certain resources like instances, subnet, security policy, public IPs and all. Those are the minimum resources which you need to have. We'll also show in the workshop like what are the resources and which you need to have. And in case if you don't have access to the paid tenancy, you can still watch the workshop because it will be recorded. But it would be preferred if you have a tenancy which has allow access to a marketplace listing as well as you don't have a resource constraint.
And if you're interested in getting an Oracle account, I think we provided instructions inside the link for the workshop itself. And then also, if you're struggling with that, please feel free to reach out and we can put you in contact with your Oracle sales reps to assist as needed.
Yep, sounds good. So and these marketplace listing of checkpoints, they comes into two flavors, like paid as well as bring your own license. For this workshop, we're going to focus on bring your own license because it allows you a 30-day license. And as Jeff already sent an email, like the partner and the end user, they can get the license. Am I right afterwards?
Correct.
Okay. And paid listing is like they are currently exposed in the US market, and bring your own license is exposed into US as well as non-US region. And this workshop, as you already know, is focused on North America region at the moment. Okay, so how, before we jump on the workshop and ask, look into the prerequisite for individual and open question and all, I wanted to focus on how the architecture will look like. So if you see from this window, like we're going to deploy 2 checkpoint CloudGuard security gateway in an HA cluster. Then we're going to have like 3 separate VCN to support that and that firewall solution. So once VCN will be the hub VCN, which will be acting as a firewall VCN. Then we'll have the web VCN, like they will act as a spoke application spoke VCN. Then we have another database spoke VCN as a separate spoke VCN. And all those 3 VCN, they will be able to communicate with each other via dynamic routing gateway. If you're not familiar with a DRG is like allows you to communicate between VCN as well as any on-prem or any IPsec, they terminate on DRG. So it's kind of router where you can, virtual router from where you can communicate to and talk to inside resources of OCI tenancy. And we're going to deploy this CloudGuard in like either 2 availability domain, or if you are using a single availability domain, they will be deployed into 2 different fault domain. And this will have the prerequisite routings, which are also configured by Oracle Resource Manager, as well as they will be also covered using the manual process.
Yeah, so just to be clear on that, what he means, and maybe you already have noticed this or you're familiar with Oracle, but we'll have 2 mechanisms for deploying all these resources. One is basically fully automated and everything is configured for you. And then there's 2 labs that cover how to build out this entire environment from scratch manually as well. And just to also be clear that this workshop isn't just available while we're doing it today during the session. It is available 24/7 all the time, whenever you want to consume it manually yourself. And obviously the video will assist with that too, to a certain extent.
Correct. Thanks, Jeff. So as Jeff mentioned, the intention is to give as much as the technical information and details about different component of OCI as well as checkpoint solution. So what we're going to do, we're going to consume Oracle Resource Manager. I'll go through the workshop outline first. The reason of consuming, like I will walk through each individual steps, but if you prefer, if you want to go with the manual step, these are also outlined on the workshop. Okay, let me know if you can see my screen.
Yep, looks good.
Okay, so if you don't have access to this workshop, let me paste this link on the chat. Okay, so this workshop has there are certain different labs which we outlined. So let me go with the introduction first. So in the introduction is, as you already know, when it comes to security on cloud, it is always a shared responsibility model where Oracle Cloud Infrastructure work with our partner Checkpoint to make sure that any workload running on OCI gets inspected, like IDS and IPS and application gets secured. So in that way, we're relying on our partner solution. So the intention of this workshop was written around allowing end user to get yourself familiar with an OCI as well as Checkpoint partner solution. So we have already covered the architecture outline here, but in summary, this architecture outline will be, let me open in the new tab. So as I mentioned earlier, like it's going to deploy 2 Checkpoint CloudGuard solution, and then it's going to deploy 3 different VCN, like hub VCN, web spoke VCN, database VCN, and we're going to use the DRG to communicate between VCNs. And there are certain.
So real quick, so just to add a little color to that. So we're using the DRG to steer the traffic into the firewall between the VCNs, and then if they're going to the internet, et cetera, or from the internet into the VCNs, everything's going to be steered. And the DRG assists with that traffic flow.
Correct.
And also to add another thing, this allows us to use virtual machine with only 2 NICs. We don't need any more NICs on these deployments. Even if you have more than 2 spokes, 3, 4, 5 spokes, it doesn't matter. You can connect it to a DRG, and you will only use these 2 NICs machines. No needs to create a multi-NIC machine more than this. Right,
and that allows you to save a lot of money as well. As we know, some of our competitors are required to deploy at least a 4V or a 4 OCPU shape to support their deployments. We can go down to a 1 OCPU shape with 2 NICs.
Correct. Yes. So that's the beauty of like a checkpoint solution, like using 2 NIC, you can support the HA cluster as well as using the DRG supports across like 300 VCNs to communicate between each other. So for example, you can have 299 spoke VCN and 1 firewall VCN, and you can steer the traffic to the firewall. So there are certain prerequisites which I have mentioned in the workshop, as well as Jeff sent an email beforehand. So the intention was to make sure that you have access to Oracle Cloud Marketplace listing. If you are new to OCI, you can always search it on, if you go into an OCI console and you search on, go into Marketplace, search all application on search bar on the top, and then you would see like a checkpoint here. So we're going to use the minimum like a bring your own license model, as well as we're going to use the checkpoint security manager to make sure that from there we can manage the firewall configuration of policies and security and zones and all. So we're going to use these 2 listings. So if you have,
hey Arun, can you zoom in on your browser for folks real quick?
Yeah.
Thank you.
So these 2, like checkpoint security management, and this one, threat like threat prevention, being your own license model. So if you are new to an OCI, you can go into OCI console and make sure that you have access to this listing, because these listings are bring your own license. So these should be available into US and non-US region. But the intention is like you have to make sure that your account is allows you to deploy the listings. Like it has to be paid account. So that's why in this workshop, when we were covering the outline of the workshop, we have mentioned this prerequisites to make sure this paid account and you have access to at minimum these 2 bring your own license listings.
Yep. And and just to be clear, if you have your own security management, in this case, R81 or greater, that would be supported as well. You can do the gateway only portion of this deployment. You're not required to deploy management inside OCI for this to work as well. It would take a few more extra steps, but you're not required to use the security management inside here if you didn't want to.
Correct. So I forgot to mention in the beginning, like the intention was like we're gonna cover the workshop and there'll be some certain break in between, like a 45 initial 45 minute. We'll cover the workshop, then we'll have 15-minute break where we cover the open question and answer. And if once we are deploying a certain like as you firewall configuration now, we'll answer open question on the chat. And if you have any open question, you can always speak up and ask us also. Okay, so before we jump on, and Jeff, do you want to check with our audience, like do they have an account on OCI tenancy?
I think it's going to be hard to determine who does and who doesn't. I think hopefully we give them enough time to establish that they need a paid account to actually go through it hands-on. Otherwise, they'll just be following along. But I think it probably now is a good time to show them the lesser resource requirement stack.
Yeah. Correct.
In case they want to deploy it with less resources, we have 2 mechanisms, and everyone can explain what we're talking about there.
Yep. Thank you, Jeff. So as Jeff mentioned, like let's move to the next step of this workshop. And if you are new to an OCI, you can follow this getting started page to create an OCI trial account and sign into your account. How to do that? These are instructions are outlined here. So at this point, we are going to assume that you already have an OCI account. But if you don't, you can always watch it, and it will be recorded and shared also. So this account, once you create the free tier account, you have to make sure that the account is converted as a pay-as-you-go account, and you have access to marketplace listings. So in this workshop, we have outlined like a different lab environment. So we're going to focus on lab 0, and I will tell you like what is the lab 1, lab 2, because using lab 0, we're going to deploy the infrastructure as an automated way, like using Terraform. But we're going to cover lab 1, lab 2. I'm going to show each individual component, like how this is being deployed and used. And then we're going to, in the lab 3, we're going to cover the initial configuration required on security management, platform as well as the CloudGuard firewall. And then we're gonna do the traffic validation. That's the focus of this lab in the end. And we're gonna do HA failover in the end also. Okay, so as Jeff mentioned, so there are two ways you can deploy this workshop. One is like Oracle Resource Manager and another is manual. For Oracle Resource Manager, we have written this Terraform code. So the first step is like a login and create resource manager. So you can download this. If you click on this resource, this zip file here, it will download this file locally. We're gonna use that, but there is a certain requirement. The one I say requirement is like as you might have noted, like Jeff mentioned, like we're gonna consume the minimum resources. So make sure that we have like only VM standard 2.1 shape, which has only 2 NIC, and we're gonna use a VM standard flex shape. So we're gonna use that. So for that, I have written some Terraform stack. Let me share it here.
Yeah, and just to rephrase, so basically the stack that's built into the workshop has a lot of like it's a I think it's a 4 CPU shapes across the board, including the spoke devices. There's two web servers and 2 database servers, I believe. And then, but with this one, it's this one he's going to share out here in a second. It's a much less requirement. So if you're restricted on available resources in your tenancy, this is the way to go. It'll be 1 OCPU shapes for the firewalls and single devices for each of the spokes. So it'll be less overhead, less cost as well. But you're more than welcome to do either one.
Yeah, so I'm gonna deploy both of them because in my environment I have resources. So I'm gonna show like what it looks like when you deploy the both. Like one of them, you can choose. I would prefer you go with the minimum requirement, so that way you don't consume a lot of resources. Okay, so let me share this zip file locally on the chat. So this zip file will allow you to deploy minimum resources. So let me show like, let me go through the workshop one step by step. The first step. So the first step will log in and create stack using resource manager. So I'm gonna choose this minimum resources which we just deployed. And then we're gonna click on it, which already saved in my file. So I'm gonna go to developer service and stack. So before I do that, for this workshop purpose, I'm going to create a new compartment in my, so in that way I don't mix and match within my resources. Okay. So you can search the stack here if you choose to. If you click on stack here, then choose your compartment where you want to deploy the resources. Click on create stack. Then I'm going to choose the downloaded file. Sorry, the file is. Okay, looks like I provided the workshop file instead of the minimum resource required file.
No worries, everyone. Now they're getting an education on object storage and sharing.
Yeah.
All good. If anybody has any questions in the meantime, feel free to put them in the Q&A or the chat.
Okay, let me. Okay, so as I said, like I ended up sharing the wrong URL, not the wrong. I ended up sharing the resources which is going to consume more resources. So I would prefer people use this one, this object storage. Okay, so there was a. Yes, I'll be covering the manual configuration. I'm going to show each individual component and an example of creating VCN and subnet. But in this workshop, the intention of using the Terraform code allow you to provision all the resources for this workshop. Okay, so this object storage link needs to be used for this minimum resources. So as I said, I already clicked on here. So I'm going to choose this browse, select my downloads. This is the workshop. So you update your name and there's a certain description and make sure that you choose your compartment. In my case, I'm choosing the workshop minimum compartment. Then you, as I said, like, okay, so this is the one I was trying to say, like, as Jeff mentioned, so you need only minimum 2 VNIC. So that's why I'm choosing VM standard 2.1 shape. But for Spoke VM, we are using E3 flex shape. And for security manager, we are using 2.2 shape. So you choose like your vulnerability domain and paste your public key. In case if you're not sure about the public key, you can always generate one using the SSH key gen manager. So let me show quickly how to generate one. So for example, if you are go into terminal and if you have already installed key generator, so that's why like it will allow you to create a public as well as private key. So this public and private key of workshop public, that's what I'm going to use it for here. But in my case, I already have a public key here. If I can choose, I can do that too. This is my own public key, which I'm using here. So in this common network configuration, the initial network strategy is like creating new VCN subnet, but you can always modify the code to use the existing VCN subnet. But since this is a new workshop, we're going to use the new VCN and subnet. And this firewall hub configuration, which has a like firewall VCN, this is our hub VCN. There's a certain CIDR. We are using management subnet and trust subnet, but this management trust subnet are pointing to the backend and the front end. So management subnet will be the front end subnet and trust is the backend subnet. Then we have certain.
Yeah, and like Arun said, all this stuff is customizable. This is just what we put in the Terraform code. So this is all everything that in here you can customize to how you need it.
Correct. So the web spoke configuration, there are certain security group policies, and this is the HA configuration. If you are not familiar with the CloudGuard HA, like you need to make sure that you have access to creating dynamic group as well as the policies. So what I'm going to do, I'm going to click on next and use the default value, which is based on the ADs and all. I'm going to use my public key, then click on create. So once I do that, the initial intention for us would be like, we want to make sure that the Terraform code works fine. So we're going to do click on plan. So plan, what it does, like in behind the scene, it just connect to each, not connect, like make sure that each resources which are creating, it has all the right format supported by OCI Terraform provider also. At the same time, all the variables and everything is working as expected. So while it populates, in the meanwhile, so the intention of using this CloudGuard Live Labs also. So what I'm gonna do, I'm gonna create a new compartment just to show. Okay, so our plan was created for minimum resources. So now I'm gonna do apply here on the Terraform Oracle Resource Manager. So behind the scene is gonna deploy all the minimum resources which we talk about. But in parallel, since it takes time to deploy the resources, so I'm gonna use this link which I shared in this workshop, and this link has a certain more resources. When I say more, it's more of like I will show like VM standard 2.2 shapes are being used for deploying this workshop. So we're gonna go into the same way stack here. Choose our compartment.
One thing to add real quick, and I put it in the chat as well, is that we also support the E3 flex shapes for the checkpoint devices as well, if that's more your preference.
Correct. So
I also pasted a link to an overview, a knowledge base article that kind of reviews and goes over the supported configurations and minimum configurations.
Okay, thank you, Jeff. So as I was saying, I ended up using more shape, but this is just for test purpose. So you can always select 2.2 shape, and this one 2.2 shape here. Okay, same public key, and in this case the concept is still the same. Like you have firewall VC and the front end subnet, because in earlier you were saying management subnet, but this one I modify the Terraform code to reflect the correct naming. So it's a front end subnet and the backend subnet and backend DNS label. Intention is still the same: web spoke, database spoke, and the HA configuration. We're gonna do create. Okay. So while our stacks get deployed during this minimum environment, yes, it's possible. Like you can pass those values using cloud init configuration. So you can use that, pass those SIG keys and all. If you're not familiar with the checkpoint quick start, so there's a quick start written for checkpoint effort. You can go there, and there's an example. Let me share. Okay. So for example, this CloudGuard HA. So if let me zoom in here. So this compute TF. So and this compute TF, like when you're creating an instance here, and then you can pass this user data. So user data is like this is populating via like cloud init script. So if you see here, we are passing the SIG key and allow upload, download any shell script which you can run. So behind the scene, what it does, there is a script written to support that. And you can look into this cloud init script, what it does, like passing the SIG keys and all those prerequisites which you can populate using that bash script. So let me share this quick start on here also. So there's another example to look into, like what are supported use case and all. So these are a couple of use cases of DRG HA use case. This is around the same architecture which we are writing, but this is like some advanced feature. So the reason of sharing this will based on the some open question, like what is the cloud init and how you can pre-populate the value during the instance creation and all, like bootstrapping and all. Okay, so this apply is being populated in the meanwhile. So when I'm going to go into my workshop maximum environment, so that's the environment where I'm using more resources. So it's going to create plan. So let me see. Okay. Oh, sorry, wait. Wow. Okay, I know why it's failed. So there is enough dynamic. I already have a dynamic group created. That's the reason, Jeff, it might fail. I may have to delete it. Or I can do something like that. I should choose. Okay, let me do that. Instead of deleting the dynamic group, I'm going to choose a different dynamic group name. I should have chosen in the beginning. Next. That was my bad, because I had a dynamic group pre-built, and the naming, I can't use the same name for another dynamic group. That's the reason it failed. But okay. So in the meanwhile, what I'm going to do, I'm going to go into maximum plan. I need to edit the job here. Edit the stack. So in that way, it reflects the another dynamic group name. So it will be dynamic group workshop maximum. Okay. So now our apply job is succeeded because of the dynamic group, because that was my on fault. Like, I wouldn't say fault, it's more of like we already had a dynamic group running. So before we jump on the manual step, let me show quickly how the environment looks like. So the intention of deploying this based on this architecture, which we had here. So what we're going to do, we should see 3 separate VCN. And since we are doing the minimum resources, we should see the flexible shape on the spoke VM, and the VM standard 2.1 for CloudGuard, and the security manager will be 2.2. So if you go into workshop minimum and compartment here, so we will see like there are 3 separate VCN. So if I click on database VCN, you will see there is one subnet, and same goes for web VCN. There is another subnet. We'll look into each individual component, but I'm giving an overview first. So for example, firewall VCN, there's a 2 subnet here. And if you click on one of the subnet of management, we are using management requires an internet gateway, but the other one we are using the DRG to communicate between VCN. So as I said, like I will walk through each individual component step by step, but I wanted to focus on as an overview, like how the instances and the VCN and it looks like. So in the minimum resources, as you Jeff mentioned, what it's going to do is going to create the E3 flagship and VM standard E3 flagship for the spoke VM, and VM standard 2.1 is for CloudGuard 1 and CloudGuard 2, and CloudGuard manager like VM standard 2.2. And so, okay, so let's look at the instance first. So let's focus on the CloudGuard 1 instance. So the intention is it should have 2 VNIC here. So one is the front end VNIC, another one is the back end. In the front end VNIC, you should have 2 different IP addresses. When I say 2 different IP addresses, if you are familiar with the NACH cluster, so you should see 2 different IP addresses here.
Yeah, and so real quick, so the first IP is going to be the IP that's assigned to it directly, and then the public IP that we've attached to it. But then all that secondary IP would be the front end, the front end subnets, floating or virtual IP. So the 192.168.1.100 in this case would be the checkpoint cluster virtual IP for the front end interface. And then it also has its own public IP assigned to it.
Correct.
And then the same, and then he's going to show you here in a second, the same will be the case for the back end. It will also have a floating IP and a directly attached IP, just like a normal checkpoint firewall.
Correct. So as Jeff mentioned, is we're gonna see two different IP, but we're gonna go through the workshop and we're gonna focus on each individual component. But I'm just giving an overview, like you would see instances are there, VCNs are there, your Terraform stack should pass successfully and all. So if you jump on this workshop, what we did, like we chose this compartment, created stack, we passed all those values and different compartment. We chose the create new VCN subnet as a network strategy, because in my case, I'm creating new compartment, but you can always modify the code to reflect existing VCN and subnet if you choose to. So the intention was, when we did the Terraform plan, a plan was succeeded. Then when we did the Terraform apply, the apply command was also succeeded. In my case, it failed first time because I had a already existing dynamic group which has a similar name. So I had to delete. I wouldn't say it. I had to change the name of the dynamic group. So the intention was showing this different CloudGuard and all. These instances are created successfully. So in my case, when we went through the two different stack, one is the minimum stack. So minimum stack was succeeded successfully. Terraform plan and apply, they were succeeded. At the same time, if I go focus on my Terraform, this is the maximum compartment. So if you see here, apply and plan, they both were succeeded. So the intention was just to show you, based on, since we are following the workshop outline, you should see these instances in my maximum compartment. They were created successfully. But in my case, I chose a different VM standard 2.2 and 2.4. But because I had the resources, but we also provided a minimum resources which you should go when you're trying to deploy a POC or a production environment. Okay.
Yeah,
now,
one other thing real quick to mention, and just kind of as an aside, if you happen to need to resize an instance or get to a larger size, it's actually quite simple. You just simply have to shut down an instance, pick a new shape size, and start it back up, and it will automatically come up with that newer size, the bigger size if you need to, or even smaller size.
So
yep, exactly.
Edit shape, from the edit shape, you can select which shape you want to do it. You can always select.
Exactly. I don't believe you can change to a completely different architecture. I don't think you can switch to a flex, but you can switch in between the VM standard shapes. Maybe I'm wrong, but I think, yeah.
Yeah. So as Jeff mentioned, like VM standards, ET flex shape is supported for checkpoint solution, and from these are certain shapes which are also supported. Okay. So the intention was, the lab 0 focus was using the Oracle Resource Manager to make sure that we can utilize the existing stack, which I showed on my compartment. And we also shared one of the minimum resources. The file is not here, but we shared into during our workshop on the chat window. And then using that, we were able to create the stack. We were able to deploy a plan, anything on open. We were able to create instances. So before we move towards the next lab, where I'm going to show the manual, I wouldn't say manual steps, but I will focus on each individual component to make sure that you understand like how it ties to the stack. Are there any open questions? Let me see. Or comments?
Nope, I think we've covered them so far. Christian and I are answering in the chat for you.
Okay.
I think we're okay so far.
Okay.
Yeah, just I would remind, it's preferable to use the question and answer box, because we can miss some questions on the chat window, because if everyone starts to do some questions, we can just miss it. So it will be easier if they use the question and answer box.
Yes.
And well, from John Timers, yeah, it's okay to just reshape the instance. The only thing is, for the gateway side, we use a solution that is called CoreXL, and every time that the instance change its shapes and also change the number of cores, CoreXL needs to be reconfigured. So you just need to go to cp config and tell to CoreXL that now you are using more cores to distribute the traffic. So yeah, to distribute the firewall kernels. So yeah, it's actually pretty safe to just turn off the machine change the shape, turn on the machine, and the new cores will be presented on the operating system, but you need to specify to CP kernel that you are using more core Excel instances.
Yep. And then obviously licensing also comes into play, at least for the gateways. Doesn't apply to management, but it does apply to the gateways. Also, something to be aware of, and you may be aware of this already, one OCPU is equivalent to 2 cores of Checkpoint CloudGuard. So when we're presented with the cores in the operating system, you actually see 2 cores for one OCPU shape, and therefore you need to license it accordingly.
Yep. If there are no more open questions, then I can focus on like lab 1 and lab 2. The intention was I'm going to show like a different VCN and how this is being populated based on these steps. Okay. So as I mentioned, like using Oracle Resource Manager, like if you saw in this Oracle Resource Manager, the last section, it says, please read, you must skip lab 1 and lab 2 now and proceed to lab 3, that is configure CloudGuard. But we're gonna go through lab 1 and lab 2, just an overview to make sure that you understand like what was the intention of creating different VCN, how the DRG is connected to different VCN, how we are launching the CloudGuard from marketplace and all. Okay, so we're going to focus on our workshop maximum compartment, because that's where I have different VCNs and all those components deployed. But the terminology also applies to the workshop minimum compartment also. Okay, so let's look into the first VCN part. So it's here like the first part is creating hub VCN. So if you are not familiar with the Oracle VCN, you can go into networking here, or you search the VCN virtual cloud networks like directly like here. That will populate to you and take you to this page. From there, you can click on create VCN and put your name here, choose your compartment, enter your CIDR here, and then once you create VCN, that's where the VCN will be created. In our case, since we are using Oracle Resource Manager, so you will see there are 3 VCN: Firewall VCN, Database VCN, Web VCN. And the first step of this lab 1 was like creating hub VCN. Within that hub VCN, you can, once you click on this particular VCN, then you can create subnet here. You can click on create subnet, put a name like test, and choose a CIDR. And for test purpose, I'm going to create a subnet, but we're not going to utilize that for our traffic validation and all. You can choose the default route table. You can choose public and private subnet. So there are 2 ways you can deploy the subnet, like regional, which is recommended, and AD specific. So think of this way: suppose if one AD fails, then your subnet and the instances they will not be able to communicate. So it's recommended to go to the regional. You can choose your DHCP option, and you can choose the security list. So in my case, we are using allow all. I will show like how the security list looks like, but you can choose that. So if you click on subnet, then it will create that particular subnet here. So in our lab 1, I'm asking end user to create front-end subnet as well as back-end subnet. Back-end subnet is private because that's you don't need to have a public IP for back-end where you're going to use the HA as well as send the traffic from Spoke VCN to the firewall. And the front end has requires a management public IP and all. So if you see here the VCN, you will see the backend is private and front end is public. I'll go ahead and delete this, but I don't need that anymore. And this is the front end backend which we created using that one. Then there is an internet gateway. So if you see here, we had created an internet gateway using the Terraform Stack. But if you are new to OCI, you can put the name over here and you can just use it. And it will automatically create the internet gateway once you click on this one, create internet gateway.
And what that ends up becoming is a default route for your internet traffic or your external traffic heading out the door.
Correct, yes. Then the intention of creating a service gateway also, because service gateway is another OCI feature which allows you instead of going over internet, you can use the service gateway to communicate via object storage and Oracle internal services. So you don't have to create an internet gateway for that. For example, if you have a use case where you don't want to go to, in our case, we created this bucket, right? So this bucket is accessible outside of over internet. But if you don't want to go over internet, you can connect to this bucket using the service gateway also. So that's the reason of we are creating a service gateway here. So
one thing to add, we do support a fully isolated environment for Checkpoint. We do not require that you have internet access. We can use the service gateway for everything we need as far as API calls and whatnot.
Okay, yes, that's true. Then this is the service gateway which we created, which is already being created here. Then this is the web VCN. So intention is the same web VCN, which has one VCN and one subnet. So if you click on your VCN here, you will see there is a web VCN which has one subnet, and this one subnet has like only one security list. So for the test purpose, we are creating a allow all. But in production environment, you have to make sure that you choose the like definite CIDR and choose a certain application. So you can choose a certain application or TCP, UDP, or SSH, ICMP, or any other application. But for test purpose, we are choosing all protocol. That's what you see here, all protocol. So this is the web VCN and the application route table. Similarly, we created database VCN. So if you see here, so there's a database VCN is also here. The same way we can create a new VCN, create a new subnet in the particular VCN. And security list, you can create the security list by clicking here. You can add the ingress rule as well as egress rule. And then you can attach that security list to your subnet. That's what we are doing using the Oracle Resource Manager, the Terraform code. So if you click on back here, you can choose this edit, and you can choose this, not this one.
That being said, if you're sending all traffic to the firewall, it's not as obviously you're utilizing the firewall to secure that traffic and
Correct.
provide access. So that's why you see the allow all.
Correct. So we want, in this case, we want to make sure that we send all the traffic to the firewall, and firewall makes a decision based on the security policies and all, and make sure that it works according to that only. Okay. So this is the web VCN which we created. This is the dynamic routing gateway. So you can go to here and the search bar and search for dynamic routing gateway. In our case, since we're using the Terraform to deploy, so this is already being created in this workshop next compartment. But if you choose to, you can create this DRZ directly here and put a name. And this is the firewall DRZ. Within the firewall DRZ, we have like we have to make sure. So if you follow this workshop and this DRZ which we created here, and there are certain firewall VCN. So we are creating an attachment for each VCN. So think of this way. Each VCN, once they want to communicate each other, we are using the DRZ to talk to make sure that the traffic goes from one spoke VCN to the firewall VCN. The return traffic comes from firewall VCN and goes back to the spoke VCN. To support that, you use the attachment of each VCN. So you can create an attachment by clicking here. Currently, you don't see any VCN because we already attached all the VCNs. But if you have new VCN, you will see it here. So they are like DB VCN, firewall VCN, web VCN. We have 3 different attachments. And each attachment, which has a route table, we're gonna go to the workflow of how the route flows. So that's where I will show like how the route table looks like. But this is also included in this section. So we have web VCN attachment here, database VCN attachment here. Then we create 2 firewall route table. So 2 firewall route table is like, think of this way. Any traffic coming from spoke VCN, you want to send it to the firewall. And how would you send it to firewall? You will send it to the firewall VCN attachment. So in my case, like I'm sending all the traffic from spoke VCN to the firewall VCN attachment. This is the firewall VCN attachment. So like when you choose your VCN attachment here, and put the CIDR, like in this case, and choose the attachment where you want to send it to. In my case, I'm sending for all the traffic because this is a workshop environment. I'm sending all the traffic to the firewall. Then we created from firewall. From firewall, think of this way. When a traffic comes from firewall VCN, you want to send it back to the spoke VCN. To support that, we have created this import route distribution table. So in this import route distribution, we have like what we did. It dynamically knows, like you create a statement here. In this statement, we are saying like use the VCN attachment of web VCN and database VCN. So once you do that, you will be able to like you create another statement. You choose the attachment here, then you choose your VCN here, and you choose like from which VCN you want to dynamically import the CIDR. So in that way, firewall VCN knows where to send the traffic, return traffic, send it back to the spoke VCN. So the intention of creating this two route table from route table. So to attaching those route table to your VCN attachment. That was the intention of creating those tables. And one more question one more comment which I want to mention, like for example, if a traffic comes from database VCN, it goes to firewall route table. From there, it goes to the firewall VCN attachment table. But how would it go to inside the firewall VCN? So that's why we have created this VCN Ingress route table. So this VCN Ingress route table is local to firewall VCN. If you click it here, so this is pointing to the firewall VCN. If you see this, there are certain route table entry here, and this is going to the firewall backend secondary private IP. If I click on this VNIC here, it will take me to that CloudGuard primary CloudGuard instance and the backend instance. So we'll see there like a 2 IP address here, 2.76. That's the IP we are using to make sure that any traffic coming from spoke VCN goes to the DRG, and then it understands the two firewall route table. From there, it goes to the like firewall. So how it looks like from the topology point of view, like this database VCN will go to the DRG. It will see the route table to firewall based on the attachment of the firewall VCN. From there, it will go to the backend subnet IP address of the CloudGuard one. Okay. So we were following this two firewall route table, then from firewall, which we talk about, then the from firewall route table, how you can create that. I showed an example of if you go into dynamic routing gateway, from there you can create two firewall route from route table and all, you can do that. So if you click here, DRG route table, you can create new route table by clicking on this one here. Then, okay, this is, and then we talk about the attachment. So these attachment, how it works, like if you go into each attachment here, from there you can update the route table. So once you click create those route table, so you will be able to see, choose route table. This is the two firewall route table and all. In firewall VCN, since spoke VCN doesn't require a VCN Ingress route table, but in firewall VCN, you have like VCN Ingress route table and all. Okay, so I'm gonna just quickly walk through route table, which we already talked about, VCN Ingress route table and all. This is okay. This is the command, which is how to use the spoke VCN traffic to the DRG. So if I go into my VCN here within my compartment, so let's pick an example of a web spoke VCN, right? So if a traffic is VM is tied to one of this subnet has a route table, and this route table I'm saying send it to the firewall DRG. So intention is like if you click on add route table, you can select the DRG, not the IRG. So from the DRG, it will dynamically know, okay, this VCN is already attached to the firewall DRG. So where you can say which CIDR you want to send it to the DRG. That's how you can send it to the spoke VCN via DRG. And then there are some certain default security lists. We already talked about the default security list. You can create a new security list, but in our case, we created a new one, allow all, and you can attach the security list to the subnet level. And you can also go into a granular level, like network security group, if you choose to. Then same thing, like I'm quickly following this one at the moment because we already have those route tables and all. via Oracle Resource Manager. In Web VCN, is the idea is remains same. You're gonna have, we have created 2 compute instances in Web VCN, which we chose, and same goes for database VCN. So Jeff, I think I will move to the next slide now, because we already covered the different component of VCN, subnet, security list, and instances and all.
Right. So I think now is a good spot to take a 15-minute break.
I think so.
Yep. And then we'll come back and we'll tackle lab 3 and 4, and we'll finish it up probably. At least lab 3. We'll see how far we get. But yeah, let's take a go ahead, Varun.
Yeah, so I'm saying if there are any question and they can be asked during the break, so that would be good also.
Absolutely. So yeah, we're gonna feel free to, during this 15-minute break, feel free to ask any questions or have us go back and review something that you missed. More than happy to. I know it's a lot of information. But yeah, we'll take a 15-minute break, and we'll be back at 15 after.
10:15. Okay.
Thanks, everyone.
Thanks. Okay, there's a comment from Arunas like, why would need a paid account? Because you would need OCI marketplace listings.
Yeah, I just answered it. So it's a good question. So as of today, the Oracle Cloud free tier does not allow for the use of third-party offerings. So that point has been raised, and I think there is definite joint interest and understanding of why we want to do that, or why that would be a good thing. So as of today, that's not available, but we are working on seeing if we can get Oracle to allow that to happen.
Correct, true. So there's a work in progress. There's no ET at the moment, as Jeff mentioned, but it's definitely a use case of at least allowing a certain number of marketplace listing within the free tier.
I'll be right back. Going to get some coffee.
Sounds good. All right. So I think we'll resume the workshop now. And if there are any open question or any help needed, you can always ask on the chat and question around QA platform. So far what we have done is like using the Oracle Resource Manager, we have deployed the resources on our compartment. And we have walked through the lab one where we show like different VCN, subnet, DRG, compute instances are pre-populated because of the following the lab 0. Then in the lab 2, we're gonna show like how we can create the instances, but we already have instances running. But I will walk through like how you can go to the Oracle resource marketplace and follow the instruction outlined in the workshop. So for example, if you're following the marketplace and as well as the manual process, so you can search the marketplace here, search for all application, and you can select the CloudGuard, bring your own license model here. So search checkpoint here. Click on, suppose we're going to select this our particular version, and we have R81. Select, subscribe to that listings, click on launch instance. Once you do that, it will take you to the compute instance page here. You enter your name here and choose your already domain which you want to use. Change the shape of like supported shape, which is like in our case you can use 2.1 because you need only minimum 2 VNIC. But if you have more license and requires more throughput and all, you can select those also. So if you want to select that shape, and then you choose, since we have the hub VCN, that's where our firewall VCN is. You're gonna choose your firewall VCN, and we have 2 subnet. Front-end subnet is acting as a management subnet for us. So we're gonna choose front-end subnet, assign a public IP address. And there was an open question like not open, like how you can pass those cloud init configuration and all. So you can click on show advanced option. And that's where you can either browse the cloud init script like bootstrap script, or you can paste your bootstrap cloud init script here. And if you're trying to have only single AD domain, so that's where you can also use different fault domain also if you choose to. And this is the like public key and private key. So for example, you can generate your own using the OCA console. Or if you have existing on a public key, you can either upload it like using browser option, or you can paste it here also. So in this workshop, the first intention was showing the CloudGuard manager. So we had to, as I mentioned, like you have to have access to CloudGuard manager as well as CloudGuard this listing. So we chose this R81 version, and we chose some certain shape. If you want to lower the shape, you can do that also, but you have to make sure that it's supported use case in your either POC or demo or a production environment. So this is the cloud init script which I was talking about. You can copy and paste it and modify it as per your need. So in the end, like once you deploy this CloudGuard instance, you would see the instance gets populated here into your compute instance compartment. So let's see, compute instances within your marketplace maximum. So the intention was, there's a one aspect which I want to mention is like in Oracle Cloud at the moment, like you can attach only one interface during the instance creation. So you have to come here, and then you have to create a new VNIC here. So you need to select the your firewall VCN, in our case our hub VCN, select the instance type, like inside subnet is which we need to select, backend subnet, and you have to make sure this source and destination check is enabled, because it allows you to make sure that firewall inspect the traffic and it doesn't follow through. So in this case, like backend subnet, you can select, and you're gonna do that, and then you select that backend subnet. So since we already have that VNIC here, I'm not gonna recreate a new one, but you can do that by following the steps outlined in the workshop, and as I showed you here also. So the intention is like once you create those VNIC, so this we're like creating this VNIC on the CloudGuard primary firewall, as well as the secondary firewall. You have to make sure those VNICs are created. Then you need to assign the secondary IP address. So if you are not familiar with the CloudGuard HA, so you have to make sure that on the primary firewall, on the primary VNIC as well as the secondary VNIC, you assign an additional IP address. Those additional IP address will be acting as a floating IP, and they will be supported use case for HA cluster. So if you see here, I'm on the CloudGuard primary, I'm creating a secondary IP on this primary VNIC as well as secondary VNIC. So if you go into your instance here, if you select one of the primary VNIC front end, you will see there is additional IP address here, 1.18, and this is the public IP because we need to, there is a use case where we are trying to connect from outside to inside also, as well as traffic wants to go or reach to internet also. So you can assign a secondary IP address by clicking on this button here. If you're trying to use the public IP, since our front end interface requires a public IP, you can choose an existing IP from your, or you can reserve a new IP address. So you have to make sure that you have right amount of public IP are assigned and used. So in front end, we have the primary public IP as well as private IP. And if I click on the back end of the primary firewall, you will see there is a floating IP is assigned on primary firewall also. But this secondary IP is not present on the secondary firewall, as you can imagine, because the intention is when the primary firewall fails, and then the floating IP moves from primary firewall to the secondary standby firewall. Okay. So if I click on the secondary firewall, if I show it here, the test VNIC, let's pick any VNIC here, then you will see there's only one IP address assigned to the firewall. So that's what we are doing in this step of this lab, like assigning secondary IP address of on the primary firewall. Then there was there's a task here which says a dynamic group and assigning the policy. So intention here is we create a dynamic group on the OCI console. So search for a dynamic group here. As you see, as you noted, like for each compartment, the workshop maximum, workshop minimum, we create a dynamic group here. But you can create a new dynamic group by selecting here. But the intention is in this dynamic group, we want to include only our instances of the instance OSID. So when I say instance, like our CloudGuard primary firewall as the secondary firewall. So you have to include those instances OSID here. And you can get those instance OSID by clicking on this each instance. And if you copy OSID here, so you can copy paste this OSID and pasting it here. So if I click on one of our existing dynamic group, so for example maximum. So if you see here, these are the instance OSID of 7NQ. So if I search it here, it should point it to one of the CloudGuard one. So this is the CloudGuard one instance. CloudGuard one here, and sending 7NQ. And this is the 7NQ which we have put it here. So once you create this dynamic group, you have to create a policy also. So for example, in each compartment, let me refresh it here because I don't see my.
And I apologize if you mentioned this already, Arun, but these steps are required to allow the firewalls to communicate with the API in order to do the virtual IP moves if a failover event occurs. So what we end up doing is the gateways are talking to the API, and we'll determine if there's a failover event. And if it detects that, it will move the IPs from, the secondary IPs from the current active firewall to the secondary member.
Correct. Yes.
These are the steps required to do that.
Right. Good thing to add in this step. It's as you can see, and since we are granting the checkpoint gateways to be the ones that communicate with the API, we don't rely on any other machine or any other watchdog or something different than our checkpoint devices to do the failover. So this reduces also the amount of machines that you need to deploy. Some I don't think it's any more relevant, but some of the sometimes some deployment needs a watchdog Ubuntu machine or another kind of third-party machines to do all the inspection. So all the monitoring. So in this case, you are granting the checkpoint gateways to communicate with the API because they do by itself the API calls to move the floating IP from one gateway to the other gateway.
Yes. So to support that, we have created a certain policy. Currently, I added like manage all resources, but if you follow the checkpoint deployment guide, which is included in this one also, you can include only certain resources like virtual networks and compute VNICs and all. So what the intention was creating this dynamic group and policy and making sure that this is tied to a compartment. So what we were following here on this one, this is the step task 4. And then the task 5 is like updating the route table. So route table, I think of this way, each subnet has its own route table entry. So we have to make sure that you assign each route table to each subnet within the single VCN. So for example, if I go into firewall VCN, if I click on the backend subnet, then backend subnet, it has its own route table, like backend route table. So if you look at from this backend route table, then what I'm trying to do here, what we're trying to do here, like this is the spoke VCN slider. We want to make sure that any traffic destined to those spoke VCN slider, they follow via DRG. But if a traffic is destined to the object storage, they go directly to the service gateway. But like there's a return traffic from firewall. That's why this backend has its own route table. So same goes for front-end route table. Front-end has its own like a DRG route table, as well as internet gateway. So internet gateway reaching outside, and these are like our spoke slider. And if you have on-prem environment, you can also use that also. So that's what we are doing in this step, like updating route table on the firewall VCN Ingress. That's another route table which I showed in the beginning, like to make sure any traffic hitting to the firewall, it goes, hitting to the firewall VCN, it goes to the firewall backend interface floating IP. This is like 2.76. This is the backend secondary private IP of the floating IP. So this is the VCN route table, backend route table, which we covered. And this is the default route table of the front-end VCN, which we are using. Then each service gateway, it has its own route table, which we talk about. Then this is a quick summary of the table, which tells you like how each VCN has its own subnet and what's the route table look like, and make sure that you like using those by clicking on each entity, you can click and update the route table if you choose to. So for example, if I go into my VCN, firewall VCN, if I go into a particular subnet, if you create a new route table by clicking on this route table icon, then if you go into subnet, you can update the route table here, like clicking edit, and you choose the route table if you want to, whichever you want to point it to. Okay, so that's like a quick overview of lab 1 and lab 2, because the reason I didn't go through each individual component, because it's time consuming. At the same time, we already have an automation. That's what we are following it. Okay, so the next good part is like the focus is around how to configure the firewall, how to do the initial configuration to support your use case, and how would you connect to security manager as well as the primary and standby CloudGuard firewall and do the initial configuration. So we're going to focus, I already have an environment running, but I'm going to follow this step just so that audiences understand how you can configure the firewall. Is that okay with Jeff?
Yep, that works.
Okay. So I'm going to focus on my workshop maximum compartment, but it doesn't matter whichever. The intention is like you have to have firewall running. So let's focus on firewall manager first. So okay, first step. So it says like I need to set the admin password first on the firewall manager, so that way I can do the initial configuration. So let me click on this one here. The reason I didn't have to pass the private key because it's already part of my SSH terminal. Okay, so the first step which we want to do is admin password. Okay. Check 1, 2, 3. Okay. So the first step, as I mentioned, like you set up the admin password, which I just did. For example, I use this sample password, but it's encouraged to use your own unique password. Okay. So the intention is like once I do set up the initial password, I should be able to go into GUI. Since my security rule on subnet allow me to connect from outside, so I should be able to connect over HTTPS. So I'm gonna enter my password here. Let me know if I need to zoom in on my screen.
I would a little bit, Arun.
Okay. Actually, when I zoom in, my screen moves into.
Yeah, you're fine. That's fine. That I think for these steps, it'll be fine.
Okay, cool. Okay, so the initial configuration, you select the next and continue with the R1 configuration. So these steps are already included in the workshop.
Yeah,
So
can you zoom in again? I don't know if it changes every time you change screens. Sorry.
Okay, how about now?
A little more. One more.
Actually, it's more.
That's fine. Let's see if that we should be fine in this screen.
Okay, so enter your security manager name. So checkpoint manager, and next, and choose the timing. Keep it default. Click on next.
Yeah, this step is pretty critical. Make sure you if you're building a manager, make sure you uncheck security gateway here. Otherwise, it'll cause you some goofy issues. So make sure you uncheck security gateway.
Click on next. I'm not going to create a new administrator, but if you choose to, you can do that. So behind the scene is going to do the initial configuration. So you want to continue? Yes. Okay, so that's the first task of this lab 3. The intention was going through each individual steps to make sure we can put the name of the security manager and uncheck, as Jeff mentioned. So it's only manager which gets deployed. And once it does that, what's going to happen is going to apply the configuration, and we're going to follow the next task for the time being. Okay. So the next task is like we're going to connect to each security gateway. So set user and password, and there's the same command. For test purpose, I'm choosing the same password, but I would encourage you to choose your own password. Okay. Since we saved it, and now I should be able to connect on HTTPS on browser. Okay, so you will see this window here. So you can update your host name here. So CloudGuard 1. These IPs get populated dynamically from the OCI. I'm not gonna change them, obviously. We're gonna choose the SIG key. SIG key allows you to make sure that a manager can talk to CloudGuard, and from there it can push the policies and configuration. So for a test purpose, I'm using the same SIG key as well as the password check at 1, 2, 3, but you have to make sure that you use your own key. And this is critical, like because since it will be a HA cluster, you make sure that you enable this check mark, which allows you to create that HA cluster on Security Manager. So once you click on go, it will ask you to, okay, it will require a reboot. So that's pretty normal. Okay. So while it happens in behind the scene, let me connect to another firewall also. So we did this one, CloudGuard 1, updated the host name, this one, enable check mark and all. We just submitted yes, and we'll jump on this step in a bit because reboot takes some time. So meanwhile, I'll focus on a task 3. So the same way, like enter password. So So enter the CloudGuard name, host name. So I'm going to choose CloudGuard 2. And, sorry. And this can be done by using Cloud Init, but in my case, I chose since I wanted to show the workshop in detail steps, and that's why I'm doing manually entering the SIG keys and all. Okay, select this enable cluster member, click on go, and it will ask you to reboot. Okay. So it takes some time to reboot the configuration as well as applying the configuration wizard. And so meanwhile, what would I focus on? So meanwhile, Jeff, would you want to cover any?
Yeah, the manager usually comes up the quickest of the 3. Is manager still going through the first time wizard? Can you click on that first tab? I'm guessing manager is still running.
Yeah, manager still.
Okay. And then check the other 2 tabs real quick. Okay. Hey, when they come back up, they will refresh their page and present it. Once those logins come back, then you can get back into those boxes. You can access, you'll actually end up accessing Smart Console. Actually, yeah. So this is probably a good point or a good spot. If you're doing the workshop along with us right now, and if you haven't done it already, make sure you have the Checkpoint Smart Console Windows application installed somewhere. That is a requirement to manage Checkpoint security policy and clusters, etc. We included a link, yeah, right there in the middle, step 5. You will need that installed and running in order to connect to the management server to manipulate and push policy down to your firewalls.
Correct.
And yes, and it does require Windows. Unfortunately, I'm sorry, I apologize if you were a Mac only user, but it will require some sort of Windows device.
Yeah, it would require a Windows VM, but if you don't have Windows VM, so in my case, I already have a environment running. So I created this smart console as a Windows VM on OCI compartment, my compartment. So you can always create a new VM within your OCI if you choose to. Like click on the instances and choose your compartment. In our case, it was workshop maximum. Create instance, and you should be able to select the platform image of Windows VM here. This one. So you should be able to create a VM here. But as long as the Windows VM has an public IP address access to the firewall manager, that's all it matters. If it is even private, that's also fine. But it should have the reachability, and it should have that smart console software, which is mentioned here, which needs to be installed here. So let me show how it will look like on the smart console.
Hey, there's a real good question on the in the Q&A I want to answer real quick live as well. It's about the jumbo hotfix. And so, yes, by default, ideally we would have the latest GA jumbo applied by, automatically. At the moment, it is just R81 base. We are in the process of updating our images to include the latest GA jumbo, but as you all know, or if you're familiar with Checkpoint, that's a moving target because we release jumbos somewhat frequently. And then there's also, there's the case where we have customers who are certified on a certain jumbo. So it ends up doing the lowest common denominator, which is typically the GA base. And then they can apply whatever jumbo that they have certified on versus us defaulting or forcing them to use a jumbo that they haven't certified yet for whatever reason. So, but yeah, that's a great question. But right now it is currently just R81 base without any jumbo. So you would need to apply that, but that's best practice obviously is to apply the latest GA jumbo after installation.
Yep. So if you see my screen here, I have a Windows VM which I created. I was able to connect using the remote desktop connection. So this is the smart console which I already installed using the given link. So which I had installed it here. But in my case, I already smart console running, so I'm not going to reinstall. But if you're following the workshop outline, you should be able to download the smart console using this object storage bucket. So if you copy link address, and this will allow you to download it locally as well as Windows VM if you choose to. But that's definitely required. Okay, so manager is fine. Okay, so once the manager initial configuration gets applied, you would see something like this. And so now you would need a smart console to connect. But I'm waiting for this Checkpoint CloudGuard 1 and 2 to complete. But meanwhile, if I choose to, I can use the smart console to connect. Should I go with that, Jeff?
Sorry, what was the question?
I was saying, like, should I just create a new manager and connect using the smart console, or wait for those CloudGuard to come up?
You should have, your manager should be up right now, is it not? Or
It's up.
yeah, go ahead and connect to it. That's fine. Oh, and I see what you're saying. Oh, you have an existing one?
No, I need to disconnect from here because this is the old manager.
Yeah, I would use your new one should be up fairly soon.
Okay.
Are you asking for the timing on the deployment of new?
Yeah, the manager should be coming up pretty quick here if it isn't already. But can you go back to your first time wizard page?
Oh yeah, manager is up. I was able to connect.
Okay, yeah, you should be able to connect to it then.
So in my case, I'm gonna connect that manager. Check 1, 2, 3. Oh, sorry. You can see my Windows, right? Windows VM.
Yes, correct.
Okay, so once you install the smart console and then once the manager is up, you should be able to connect to the manager given the admin and the password which you chose. Okay, so it looks like both of the CloudGuard they came up healthy and they rebooted successfully. So what we're gonna do before we move to the lab 4, we should complete the prerequisite of creating those route entry. Okay, so we were here on this tab. At this tab of CloudGuard 1 was rebooted. So once the host reboots, we need to create the static routes. I will tell you like why we are creating that. So admin check 1, 2, 3. Let me refresh. Okay, so the reason of creating this, so think of this way, any spoke traffic wants to communicate and inspected via firewall. So the traffic comes to the DRZ, from spoke traffic comes to the DRZ, it goes to the firewall. But now the firewall, once the inspection happens and you do the IPS and IDS and everything, then you want to make sure that traffic gets back to the spoke VCM. So this firewall needs to have its own static route entry to ensure that this web spoke sider and database spoke sider gets routed by backend subnet, because we have a route table on backend subnet and the route table sending traffic back to the DRZ. So to support that, you need to have static route to supporting for this spoke sider on the firewall. So that's why in this lab environment, in this task 3, we are asking to create a spoke sider. And the gateway would be the backend subnet default gateway. And the default gateway for backend subnet is the first IP of the subnet. So in this case, it was 192.168.2.0/24. So 2.1 will be the first IP. So to do that, you go in. If you see a lock icon here, you can click on here. But if you don't see anything here, you just unlock that configuration. So click on IPv6 static route, click here. Okay, so for test purpose, I'm using 10.00/16, but you can always.
Arun, just so you know, you're actually on your manager, so you don't actually need to do that on your manager. So you want to go to your firewalls.
Oh, yeah, I was on.
So you're doing the same. You're doing the right step, but on the wrong box.
Yeah, okay. Yeah, I don't need to do that on manager. You're right. I was. Okay, so this is the IPv6. Click on add, enter, and same goes for the another one. Check CloudGuard 2. So this is CloudGuard 2. Click on here. Okay, so now the routes are present on both of the firewall. So this task 3 was about the route, and task 2 and was the route, as well as task 3 has the CloudGuard initial configuration adding the routes. Now we were able to connect. I already had the smart console running on my Windows VM, so that's why I didn't went ahead and reinstall it. But I was able to connect to this manager here. So once we did that, as you see, you will see this window here. As soon as you connect, this is our public IP and the private IP of this manager, which we use. So at the moment, okay. Now the next step is like we want to add the cluster of firewall within this via smart console and through the manager.
Can you zoom in, Arun? Thank you.
Yep. Okay, so to add a clusters in our smart console, you click on the gateway server. I'm gonna show like how you can add the cluster. So what we're gonna do, we're gonna follow this instruction here. So let's jump on this smart console. Let me move it a little bit. Okay. So click here, cluster and cluster. So you will see you're gonna select the wizard mode. So we're gonna put a cluster name as like a checkpoint cluster. Okay, but in the cluster IP address. Okay, that's the comment here. So if you see here, I have mentioned like you need to enter secondary public IP address associated with the primary interface of the CloudGuard instance. So how would you get it? Like you go into instance on Node console, go to CloudGuard first instance, then go to the primary interface, which is our front-end interface. Go to the primary VNIC, and you choose that secondary IP address, private IP, because this IP needs to be entered there. So that's what I have mentioned this step here, like the front-end primary VNIC interface, secondary public, public IP, not the private IP.
Yeah, it's not super critical that this, you can either actually use either one, but the public works fine.
Yep. Okay, then click on next. Okay, now what we're gonna do, we're gonna add within that cluster, we're gonna add each individual member. So it will be CloudGuard 1. So if you follow this instruction here, the next step was adding the new add cluster, CloudGuard 1 instance. So we're gonna enter the CloudGuard 1 name. And then the IP address is enter primary interface private IP address of CloudGuard 1. So we need to enter the primary IP. So if we go here, this is the primary interface front end, and this is the primary IP 1.25. And this is the secure internal communication. So remember, like we had entered the SIG key. So I'm going to enter that and make sure that it works fine.
And if it wasn't clear, that's just a one-time password. You don't need to save it for later use.
Correct. So as you see, the trust was established. So hit OK. So it will add that CloudGuard 1 here. Similar way, we need to add another cluster, which is CloudGuard 2. So let me get the IP first. So this IP will be same, but if you choose to, you can see it on each individual NIC, but IP address in the primary interface, private IP, the first IP will remain same, like 1.247. So that's what we are saying here. So we had the CloudGuard, we added CloudGuard 1 here. We added that one, we established the connection. Now we are doing the CloudGuard 2. We are entering the private IP of primary interface. So once you enter the SIG key, which you're going to utilize and trust is established, click OK. Okay, click on next. Okay, so at this point, we added both of the CloudGuard 1 and CloudGuard 2, right? And you should see both of them on your security manager. And the next step is you click on next and you just finish. So once you, what we're going to do, we're going to finish it here. So you should see like CloudGuard 1 and CloudGuard 2 gets populated here. So in the next step is like as you're following along with the workshop outline, you should see CloudGuard 1 and CloudGuard 2. Then the intention is we're gonna use the each 0 and each 1 interface of each 0 and each 1 is like a front end and back end interface of firewall. And each 0 is going to be participating as a cluster, and each one will be participating as a cluster as well as a HA sync configuration. So what you're going to do, you're going to double click on your CloudGuard cluster here. Go to network management, get interfaces with topology. Click on yes. So once you do that, it will populate the IP addresses of both the interfaces, both the firewall, CloudGuard 1 and CloudGuard 2. So that's what we are showing it here, like you populate both of them here. So you will see, then click on the each one interface, the IP address you will see. So click on the each one interface here. And we need to enter the IP.
You change the network type to cluster at the top there. Yep.
Okay.
And then we'll grab the floating virtual IP.
Correct. Of the CloudGuard primary.
The private IP. Yep.
So what we are doing it here, since now the manager has the cluster and the cluster has the each 0 and each one, which is like front end and back end interface IP of the primary IP address. But now we want to make sure that we populate the floating IP of front end and back end from primary firewall to the cluster. So that's what we're going to do. We're going to go into CloudGuard 1, go to the test unique, go to the front end, and use the floating IP. Click OK. And the second one, we're going to do cluster plus sync, as I mentioned on the outline here. If you see, follow it, we did the cluster each 0 1 now, just now, and we are doing the each one cluster plus sync and secondary private IP address of secondary interface of CloudGuard 1 instance. So we are in the on the same instance. Go to the VNIC again. We're going to go to the backend interface. And we're going to copy that IP address here. And click OK. So once you click OK, then this pretty much about the initial configuration, but you click on yes. If you want to skip it, you can always skip it, that message which was populated. So for the test purpose, we're going to update the initially purpose, we're going to update the security default cleanup rule. For test purpose only, I'm allowing all, but in your production environment or demo or POC, you have to make sure that you allow only required policies. So currently, in my workshop outline, you will see like I'm not updating the track, but in my next step, I was updating. So if you choose to, you can update it here. So you will see like click OK button and allow all, select the accept icon. I wasn't updating the track log level, but you can always update it now or in a later step of lab 4. So you just do publish your changes.
And if you're not familiar with the checkpoint, publish is essentially just committing the changes to the management server database. It's not actually pushing the policy, but the next step will actually push the policy down to the firewalls themselves.
Correct. So and then you're going to push the policy, install policy. In our case, we are pushing on the whole cluster, both of the member. So in summary, like you would see like on the status task manager taskbar here, like what's the, and if there is any error and anything like that, then it will populate here. But I know it won't run into this workshop because we have tested it out.
Now you jinxed us, Arun.
Yeah. Okay. Instruction succeeded on checkpoint cluster, and give it like a couple of minutes, and there's all those check status marks, they will turn green. So that was like the lab 3, where we had the hands-on experience of connecting to each CloudGuard instance as well as manager, using the smart console to add a cluster, making sure that we populate the topology of IP addresses and interfaces, making sure that we use the floating IP of primary firewall front end as well as backend interface to ensure that it gets populated. And we allow the basic allow all policy in the beginning.
Perfect. So I think it's another good spot to take like a quick 5-minute break. If anybody needs to go use the restroom or grab a coffee or caffeine, etc. So let's take 5 minutes. We'll be back at 5 after.
Okay, sounds good.
Thanks, Varun.
Welcome.
All right. So I think we can get started again. Do our traffic validation.
Yep, that's the fun part. Like now
Sure.
the good part is we want to make sure that we use the firewall to inspect the traffic coming either towards Spoke VCN or from Spoke VCN and like in between Spoke, in the web Spoke and database Spoke VCN. So that's the beauty which we want to test it out with the checkpoint partner. Okay, so as in the last lab which we covered, we were able to create the cluster, everything is there. So now we're going to focus on the initial deployment of north to south inbound traffic. So when I say north to south inbound traffic, is my intention is traffic coming from outside, could be internet, could be on-prem, or could be anything, and it goes to the firewall and we inspect the traffic on the firewall. So in my case, for this workshop, what I've chosen is like I'm using a internet like outbound connectivity towards Spoke VCN. So to support that, we have to create some object on firewall as well as some security policies. So the first object which we need to create is like in our case, we're going to choose web application one VM and a database application VM. Those are their own private IP. So we're going to grab those IP from our OCI console. Then there is an object called front-end private IP. And think of this, so this is more of a front-end cluster private IP of primary firewall, like the floating IP. The reason of creating that object is because we're gonna use this instance. If I click on the CloudGuard one, we're gonna use the public IP to connect from outside. So if you click on this CloudGuard one, attach VNIC in front end. So our intention would be we're gonna use this public IP to connect from outside, because in my case I am using the internet gateway and all. But if you have some another way to connect from outside to the Spoke VCN, you can always do that. But for this workshop, we are using this public IP to connect from outside. So that's why we're going to use this IP address to create a network object, as well as the private IP addresses of one of the Spoke VM, like in web Spoke and database Spoke.
Right.
We're going to.
Somebody asked a question earlier too. We can assign additional floating IPs and attach those directly to devices or load balancers or whatever you want, just like you would with a normal firewall behind this. But in this case, we're just going to use the single VIP, and you'll see it'll make sense here in a second once we get a little further in the lab what we're doing. This is one way, but it's not the only way by any means.
Oh yeah, that's a good question. So let me share something recently, like with Checkpoint and OCI recently published a reference architecture. So I'm not gonna go into detail, but that's the focus which I wanted to focus here. Like this is one of the reference architecture where you have like a NLB. Behind the NLB, you have like a couple of firewall. They're acting as an active, and you have separate VCN, like North Hub VCN for the north inbound traffic. Then you have South Hub VCN, which is where you're deploying the CloudGuard in HA cluster, like active passive mode. And then you use the DRG to communicate between all those VCN. So if I can share this link on the chat here. If you choose to, you can like you can understand. But our workshop is not focused around this reference architecture. Okay. So back to our workshop is like we're going to create these 3 different objects. So let's connect to our remote security manager here. So as you see now, everything is green. So it's fine. Click on new host. So we're going to choose the name of web application VM first. And
before you create the other 2 objects, I'm going to paste in a couple of links for you to use it. I'm going to have you create objects a little bit differently to show people that there's multiple ways to do this. And if they don't want to use the GUI, or they don't want to use the point and click method, there's alternative ways to do it a little quicker if they so choose.
Sounds good. Okay. So meanwhile, while Jeff posts those link here, so we're gonna create those objects. So we're gonna choose.
Go ahead and create the web app one if you want.
Okay. So once that
Yeah,
object gets, go ahead, sorry.
You have to put in the IP address of your database. So anyway, so what I'm having him do is he created one manually with the web.
Correct.
I'm gonna have him do the same thing, add an object, but using the CLI that's built into the smart console or the command line. So on the bottom left, Arun, there's a command line icon in the blue column there. Click on that.
This one works now?
Up one, nope, command line. There you go. And paste in what I sent you in the chat, or what's in the chat there.
Oh,
And then you'll have to put in the IP address of the database app device.
Okay, so this will be add host name db IP of one. Let me grab this IP here.
And actually, put in the words IP address and their IP dash address as well. I forgot to add that for you. Sorry. IP dash address. There you go, enter. Perfect. So that is another way of adding an object. You can see it there in the top right. Yep.
And there's another way, like for example, if you already have an object here from the GUI or console, like however you choose to, you can clone it. So
Correct.
if you click on clone, then it will just clone this particular value. So that's what we're gonna do with the front-end IP. So front-end private IP here. Go to our instance, which we had the front-end interface, private IP. This is the private IP. Click OK. So there are many ways you can do the CLI, and I'm guessing API is also supported as well as.
Yep, exactly.
All right. So those objects are created, network objects. So the web app is created, front-end private IP is created, DB app is created. Now we're going to create two of the service, as you can always use the CLI, GUI, and API, whichever you prefer. But the intention of these services is like we're going to create two different TCP services, like 177 port as well as 1778. The intention is like, since I'm using the public IP to connect from outside, I want to make sure that traffic for 1777 goes to the web spoke VM, and 1778 the port goes to the database spoke VM. So that's why to support that, I'm creating two different TCP service on my firewall. So you can find it out here. Go to new, more, services, click on TCP here. Port 1777. Okay. Okay, click OK. So now these TCP objects are also created for both of them, web spoke as well as database spoke VM. Now the intention is we have to modify the security zone on the ETH0, the front-end interface, and to support our net policy, because we are using net to come from outside, like we're going to use the public IP, the front-end private IP, to reach to the spoke VC and VM. So to support that, we have to make sure that we allow the net policy on the security zone level. So that's why we're going to modify the ETH0 interface. So to do that, you can go to your cluster here directly. Click on here, go to the network management, go to the ETH interface. Specify security zone. We're going to use the external zone and click OK. Yeah, then we already enabled the logging in the last step, so I'm not going to re-enable it. But these are the three different net policy which we need to do. The first net policy is to make sure there is no management traffic doesn't have impact of corresponding the other net policies. And the second net policy is to make sure using the front end public IP, which will get translated to the private IP as soon as it hits the OCI. And then using the 177 service, it goes to the web spoke VM. And same goes for the database side, like using the private front end public IP of the floating IP, and goes to the TCP 1778 port, goes to the database VM. So to do that, we have to create the net policy on the firewall. So what we're gonna do, we're gonna go into security policy here, go to the net. So click here, add rule to top. So let me put the name no. Everything can be done from CLI as well as API. I'm just showing the GUI part.
Yep. No worries.
So let me choose security manager. Any service, translate service. Okay, that's fine. So I can clone it. Let me see. If you want, I can clone it also, or let me just add it on the bottom. It will be easier. Add rule below.
Gonna answer a question live here for John. So yeah, we can actually add additional secondary IPs to become floating IPs and then assign them statically to individual, either a load balancer IP or to a physical, to a VM in the background. So we would not have to do port translation for everything like this. This is just, we're just using this method for the purposes of the workshop to use just the single VIP to tie to two different VMs.
So external John, front-end private IP. VM.
And to answer the follow-up question for John, yes, that is correct. You would need another floating IP on the inside as well to relate to it, correct?
That's why the new architectural design that uses the active members with the load balancer in front is actually a good use case in other, or good use case if you will use several public IPs, since all the public IPs is managed through the load balancer instead of secondary IPs of the checkpoint gateways, and they will be distributed evenly on all the members instead of one active and one standby member of the HA. So it will depend. Those things is the things that you need to, or we need to help you with in the architectural design. It's how you will use it, for what you will use it. And in that case, we can provide you if, I don't know, if HA for public, for Ingress is better for your applications, or maybe a scaling group is better for your applications because you will have several requests instead of static requests.
Right.
Okay. So what we did, like we created three net policy. One is for making sure management traffic is not impacted. So there is no net rule on the top. And then we are using the web app net rule. So the idea like external zone, which is tied to the each zero interface, which is like the front end. So the intention is like as soon as the traffic hit with the public IP goes to the destination will be like the private IP of the front end, and then it gets translated to the web VM, and as well as the port will be like SSH port. Okay, sorry, I forgot to select one of the port. Let's see. Translated destination. This one and this one. Okay, yeah. So the front end using this 177 port and goes to the web VM, and it responds on port 22. So the intention will be like using 177 port, we will be able to connect to the web spoke VM. Using 1778 port, we will be able to connect to the database spoke VM over port 22. So that's like the task one is like when north-to-south inbound traffic, which we just did. We created the object, we created the allow the security zone to the interface, we created the net policies, we created the services and all. So you can do a sanity check just to see everything is fine. Then what we're gonna do, we're gonna create the publish and install. So let's publish our changes. Click on policy, install policy. Empty address translation rule.
Number one. Oh, your source needs to be security manager.
Oh yeah, source of, yeah, this one, right?
Yep.
So this will be
Checkpoint manager, I believe.
this one.
Yep.
Yep. Yeah, actually that's what I have meant. I was looking at this security manager. So this is the security manager will be our checkpoint manager. In our case, we had entered the security checkpoint manager. That's why it was different. Okay. So publish. Okay, so now as soon as this policy gets completed, so intention would be like we are inspecting the north to south inbound traffic. So using those public IP and the ports which we have configured, we should be able to connect from outside to the spoke VM. Okay, let's see. Okay, it got successfully completed. So if you see from the workshop outline, so as soon as it got completed, we were able to connect from outside to those individual web and database spoke VM. So what we're gonna do, we're gonna go to this front-end interface of the CloudGuard primary firewall, go to our SSH terminal. So as you see, using port 177, I was able to connect from outside using the floating IP of public IP of the primary firewall. And we were able to connect to the web VM. So this is like 10.0.0.36 IP of the instance. So if we go into instances here, this is the 10.0.0.36 IP using port 177. Similarly, like if I follow it here, and let me open another session horizontally. So as I said, let's see. Okay, so this is like 10.0.163 IP of the database VM. So that's the database VM, which is like 10.0.163 IP. So the intention was showing this, and the first task of this lab is like showing north to south inbound traffic using the net policies and the routes which we have already added in the previous lab. You are able to connect from outside to the firewall. But if you are curious to see how the whether it is hitting the policy and how it looks like, you can always inspect the traffic on security logs monitor. So let me go here. Oh, sorry, it will be in the security, right? Logs. So this is the port 177. So this is my public IP. And you can see if you try to select it, it will tell you like the translation happened, which net rule got impacted, what is the IP it got translated to. So you should be able to see the additional details here. And you're saying it's hitting the CloudGuard one, right? That's our primary firewall. Same goes, okay, now we are gonna move to the outbound traffic. So the outbound traffic, think of this way. Outbound is like if traffic wants to go to the internet and all, so it will follow the same path, like in our WebSpoke VM. WebSpoke will hit the DRZ. From the DRZ, it will go to the ingress route table of the VCN. It will hit the firewall, and firewall it has its own route to go out, right? There was a default route on the firewall to go out via the out front-end subnet gateway. So the intention will be like we need to do a netting on the firewall to see any IP gets translated and uses this outside interface to go out. So to do that, if you see here on this north to south outbound traffic, we are going to each object of VM, and we are selecting the address translation. So that's what we're gonna do, and that's the only, because we already have the policy allowed all, so we don't have to, for this workshop we don't have to, but in production environment, make sure that you allow the required policies only. So let me click on app object here. Before I do that, let me show it here. If I do ping google.com, it doesn't work. So intensively, I'll click on this one, click OK. It will add a net rule, which I'll show you how it looks like. Which one I did. So this is for web app VM, and similarly do that for DB app VM. Click on OK. Okay. So if you see, it will dynamically add this net rule, hide net rule in your net policies. So publish your changes. We already have the policy allowable. You don't have to run it in a new policy, and just install the policy after you publish your changes. Cool. So policy got applied, and now if we go into one of a Spoke VM, try to do ping google.com, you should see traffic goes through the outbound traffic. And if you are curious, you can search the IP here. Let me find it out. You know, I have to search.
You want to look for the source?
Source would be that. Yeah, okay, this one. So if you see here, this 10.0.36 is trying to do ICMP request to the google.com. So that's the thing which you will see on from each individual spoke VM. So that covers our second task of this traffic validation, outbound traffic. Okay. Now the another validation which we want to do, we want to see, okay, if a traffic comes from web spoke to database spoke, and if it gets inspected by a firewall. So for example, it's a web VM wants to talk to the database VM or another spoke VM, which you have like in another spoke VCN. We want to inspect the traffic via firewall. So then you have to understand this concept is very important. Like when you're trying to create a spoke VCN insider, and if you want to inspect the whole spoke VCN insider, then its recommendation is like you allow the whole CIDR as part of that subnet. For example, if you are like 10.0.0/24, then you assign the subnet to in a way that you consume the whole CIDR. So in that way you can inspect it. But if there is no requirement as such, you can always granular level, you can define it. But the recommendation would be like if you want to inspect the whole CIDR, it makes sense to include the whole subnet as part of the VCN CIDR.
Yep, good point, Arun. Otherwise, you can potentially subvert going through the security of the firewall. So if you have, multiple subnets inside there, you can steer the traffic to each other without going through the firewall.
Correct. That's why, like for example, if I have another web app 2 VM, which is sitting in a different CIDR, and if they want to talk to web app 1 VM, firewall won't know about that traffic, because firewall knows only when the traffic exits from the particular VCN and it reaches to the DRZ, then DRZ send it to the firewall. Okay, so web to database spoke VM. So currently the policy is already there, as I've been saying that in the beginning, like allow all policies there. So that's why I don't have to explicitly put a route or create another policy. I can use the existing policy. So if I try to go to one of the spoke VM, let me cancel it here, IP address.
Not that one. You want to do the 10.0.0.36? Yeah.
So 10.0.0.36 is fine. Same goes for if I here ping 10.0.1.63. It works fine here. And we should see some of the, let me keep running for the web spoke VM. And you would be able to see the logs on your smart console. Okay, this one. So if you see here, this web VM is trying to reach to the database VM, destination DB VM, and is doing the ICMP request, like ping. You will see the ping logs on your smart console policies. That's like east to west traffic. So that's another, like we cover the north to south inbound, we cover the north to south outbound, then we cover the east to west traffic between spoke VM and make sure that firewall gets inspected. There's another use case people use like make sure that when you remember, like I was mentioning, like we had a service gateway, and service gateway allows you to connect to object and bucket directly. I might not cover it in this workshop. If you want, I can cover it. You want me to cover the Jeff?
Say again, sorry.
Do you want me to cover this one, east to west object storage?
You don't need to. That one's pretty self-explanatory. So basically, the idea there, when you do this, when you go through the workshop, what you're doing is you're creating a route to that, to the object storage. But then, because the service gateway definition is there, it actually doesn't have to traverse to the internet. It just stays all private. Correct.
So for example, like you create an object bucket. Within the bucket, you upload a certain object. It could be file, it could be anything. But the intention is like you allow a certain CIDR. In our case, I was using the S-band region. So S-band region has certain CIDR. You can look it online, like what are the certain CIDR for each region on OCI. Then in the intention is to reach that certain CIDR. Earlier we were going through the default gateway of front-end interface. But now we are not going through that because we are going through the trust subnet default gateway. And once you add that route table into each CloudGuard firewall, and then this is the backend route table. So this is the intention is, as soon as the return traffic comes, then it will go to the service gateway to reach to those object storage bucket and all. So this is an example which I included here, and you will see the traffic is going through the trust side, sorry, backend side, instead of going to the front end subnet. Okay, so the next step is like I've been saying this cluster is deployed in high availability, and we have created dynamic group and all the policies and all. But we want to make sure like whether the HA kicks in the firewall when a primary firewall fails, and the standby picks it up, the floating IP from the primary firewall, and like which we have been saying that floating IP gets assigned to the primary firewall in the beginning, gets transferred to the standby firewall when the HA failover happens. So what we want to test it out in this validation is like this front end public private IP on the front end interface, and as well as another interface. Let me open another window. So this is the CloudGuard 2 instance, and you would see like there is no floating IP here. So what we're gonna do, we're gonna perform the HA failover from the CLI, and you can always reboot the host, but CLI is pretty quick and easy. So the idea is like you would see the floating IP gets moved here. And to support that, CloudGuard, Checkpoint already has a plugin supported on CloudGuard, and that plugin, what it does, it talks to the OCI APIs, and using those dynamic group and policy and using the instance principal mechanism, it moves the floating IP from the primary firewall to the standby during the failover. So this, like what I was showing in the beginning, like the CloudGuard has a floating IP assigned it here. So we have the floating IP on the backend as well as the front end interface of the firewall, and they will be moved to the CloudGuard 2. So currently CloudGuard 2 doesn't have the floating IP here. So to do that, what you do, like as I said, like you can always reboot the host and all, but we need to perform this prerequisite because of there's some comment around R81 release, but it might be resolved into the future release. But Jeff can comment more about that. But for the time being, we're gonna test it out using the CLI. So what we're gonna do, we're gonna connect to each firewall instance. Let me connect to the firewall instance first. Okay, this is the CloudGuard one. Let's do that edit session.
Looking for that command there.
No, horizontal.
Okay.
Yes. So this is CloudGuard. So we are in CloudGuard 1 and CloudGuard 2. So intention would be like we're gonna go into expert mode. We're gonna set up an expert password and then this prerequisite script. You need to enter a certain password. So okay, so now we are in expert mode. So we're gonna run copy these two commands and run it on both the firewall.
these commands will not be necessary in the near future, but they're just updating the certificate bundle.
Okay. Okay. So now to kick the failover, so there are many ways you can do that, like either into, if you're already into cluster mode, expert mode, so you can run those commands. And if you are not in expert mode, you can run those commands as it is from the simple console of SSH console of CloudGuard. So what we're gonna do, and the first command, as you see, like it says set cluster member admin down. Then the primary firewall, which we're trying to bring it down from the cluster member. So if I click here, set cluster state first. So you will see.
Show.
Oh, sorry, show. Okay. So currently you see CloudGuard 1 has an active and CloudGuard 2 is standby. So using this command, we're going to bring down the first one, CloudGuard. Okay, so it went down. Sorry, I forgot to show one thing first.
Yeah, I was just saying the pings will restart here in a second once the IPs get moved.
Okay, so the intention, like once the CloudGuard went down, the second firewall became active, and behind the scene, like based on that dynamic group and policy which we created, the IP should move over from primary firewall to the standby. So if you see here, the IP just moved away. It got moved from primary firewall to the standby. So if I click on the CloudGuard 2, if I click on attach VNIC and go to any of the VNICs, you would see the floating IP got moved here. Same goes for the front-end VNIC. The IP along with the public and private IP, they moved here. And you would see as Jeff mentioned, there was some drop because of the IP move over. But after that, the traffic started running normally. So that was the on the traffic validation last step. It was to show like how the HA failover works fine. And I know I have included some screenshot of the smart console, but I showed it into CLI also. As you see, like on CLI, and one of the firewall became down, right? And if you want to bring it up, you can always bring the cluster up. As soon as bring this cluster member up, it will become standby because the other one is currently active.
Yep, exactly.
So CloudGuard 1 is the standby, and unless the CloudGuard 2 goes down, then only the CloudGuard 1 will become active and it will have the floating IP. Any open question on the traffic validation part?
Doesn't look like it. There's a question about whether or not the commands are in the SK. I don't believe we have the cluster commands in the SKs. Let me check just so I'm not.
Maybe in cluster XL ATRG.
Yeah, for sure. Yeah, for sure in there. I don't believe it's actually in the, I don't think we mentioned.
No, in any of cloud related SK, I don't think so, because this cluster XL commands is not actually a cloud related command.
It's not, yeah, they are the same commands you would run on a on-prem cluster XL deployment. I will paste in the Oracle cluster SK into the chat as well. I just verified though it does not include the commands for failover.
Yeah, another way to use it is just reboot in one machine, but it takes more time. So maybe that's why we use the cluster XL admin down and cluster XL admin up, or set cluster member, whatever commands. But I will pretty sure that is there on the cluster XL ATRG. And again, the way that the checkpoint gateways works, related to cluster technology inside the kernel is exactly the same, cluster XL. The failover event is not the same because we cannot use GRP or some of our traditional mechanism. Is everything done by API calls and moving the public IP and so on. But all the synchronization and stuff that is done on the monitoring, health checks, and everything is done by the cluster XL traditional mechanism.
Well, we'll stay on here for a little bit longer. If there's any additional Q&A, I know I appreciate you guys hanging in there for as long as you did. I really do appreciate it. Hopefully it was beneficial. I think you probably have our, well, actually, if you don't, I'll just go ahead and put my email address. If Arun and Christian want to put theirs in, that's totally fine. I can put them for them. Feel free to reach out via email. Happy to assist going forward. Now, just a reminder, in case you want to attend another one, we are actually having 3 more of these sessions this month in different parts of the world. So I think next week is, I think it's APAC. I think it's New Zealand and Australia and Asia regions, Japan, China, etc. And then the week after that is Europe, and the following after that, the last one is Latin America. So
yeah. In order to answer the John Timers, sorry, dynamic object on the rule basis in HA deployment is not needed. For outscaling groups or more distributed deployment, it is needed because there is not only one member that is doing everything. In the deployment of an HA, actually the cluster object from the management side is only one, so you don't need to specify any dynamic object. I don't know where you saw it. I think what Arun used it was zone object.
yeah, we use the external zone object,
right,
to
on
define.
one of the on one of the rules that I saw a zone object, which is actually zone based or for zone based rules, but it's not a dynamic object. It's zonal. It's actually attached to NIC members, and that's the way that we declare some zones.
Yep. We will also be posting this probably to checkmates, I'm guessing, in other places. I'm not positive, but we will have this recording available as well. So if you want to go through it and listen in again, that'll be available. Thanks, Nikhil. Appreciate it. This is our first run at this, so yeah, I appreciate it, Arun. You did an awesome job.
Yeah, I will answer. I will answer another question. Yeah,
yep.
I will answer another question from John. Yeah, in your case, as you state, you have an MDS that creates an stealth rule. The stealth rule will create a non-possibility to communicate with the IP addresses that belongs to the checkpoint gateways, other than the secondary members, sorry, secondary IPs. So yes, in your case, or what as I answer it, my shot will be to create the rules above the state rule, but only allows the port that you are using for the port address translation. So in that case, you can still has the least privileged approach on the rule base, instead of only allowing everything to the checkpoint gateway. And from there, you can specify the port address translation on the NAT rule. So even if a port is open and you don't create a NAT rule, nothing can get into your VCNs because the checkpoint gateway will never do the NAT rule and actually will never translate this incoming packet into some VCN destination. So yeah, you understand, right? But yes, that's a change of mindset. So you cannot continue with the stealth rule, disallowing everything incoming to the checkpoint gateways, because you will need to use it as a port address translation device.
And that would fix the issue probably in Azure as well, correct, Christian?
Well, I was not touching the Azure because this is an OCI session. But well, yes, in Azure, the virtual machine scale set, which is the one that is facing this issue, because is where you will need to select the only one IP. Well, also the HA actually. If you're using the virtual machine scale set, you can actually do automation based on the new CME capabilities. So in that case, the rule, the NAT rule, and everything can be automated by tagging in Azure side. So you can just tag everything. You can just tag everything on the on-prem side, and sorry, you can just tag everything on the Azure side, and the CME will create the rules. If you're using the central management on-prem, it doesn't matter because everything is related to API calls. The API calls on the clouds is through the public API endpoints. So actually, what you need to do is allow to your central management or to your management station to reach internet in order to reach all the API endpoints. Configure the service principals or configure the access keys or API keys to allow them to access and read your resources in the cloud. And then you can automate these NAT rules, at least on the VMS side of Azure and also the HSG side on AWS. So in that case, you can actually simplify the NAT and access management.
If anybody has feedback or ideas for additional sessions similar to this, or enhancements to it, we're all ears on that as well. I'm personally a fan of this format where we try to keep it informal, just get right to the raw details and hit it live and show you the real thing instead of PowerPoints. No offense to PowerPoints.
And also, John, for NAT rules in an HA deployment, you are referring to cluster members. So HA deployment, it will depend on it will depend on the it will depend on the cloud that you are referring to. In the cases of OCI, since actually your reply packets will go only to the active member because the default rule is actually pointing to the secondary IP that is managed by Cluster XL, you don't require any dynamic object. In the case of Azure, if you're using an HA, actually the failover mechanism is managed by the load balancers. So the load balancer will do the reply packets only to the active member. So it's not required also. If you are talking about the auto-scaling groups or virtual machine scale set, you will need it since there is no persistence mechanism because the first packet comes to the public load balancers and the reply packets doesn't go to the public load balancer, go to the internal load balancer. So in that case, you need to specify or create and source net. And the source net in virtual machine scale set is actually managed by the dynamic object, since you cannot specify one IP address because we don't know the IP address that every single member will belong. So in that case, for virtual machine scale sets and out-scaling groups, you will need to use the dynamic object. But the main purpose of the dynamic object is to create persistence mechanisms, since there is no other mechanism to create persistence. And the checkpoint gateway is a stateful gateway inspection, sorry, stateful inspection gateway, and we cannot support asymmetric routing.
Also, as a quick follow-up, we will be sending out emails just to follow up on the training and get feedback, and also send links to the recording and other links as necessary that will be supportive of what we did here today, including like the lower resource usage version of the workshop in case you weren't able to go along with us side by side live. And maybe we'll, once you get an account created or whatnot. Appreciate your partnership. Appreciate your time, guys.
I will stay for one or two more minutes. And as Jeff mentioned, appreciate everyone joining today's workshop.
Yep. Thanks, Arun, for your help. Really appreciate it. Thanks, Christian. Thanks, Jonathan.
Yeah, thanks everyone. Thanks Jeff for inviting me, and thanks Jonathan also.
Thank you guys. Well done. Really appreciate it. Thanks to everyone on the call. And please feel free to contact us. Any questions, issues, ideas that you may have.
All right, everybody, have a good day. Take care. Be safe.
All right. Thanks, everyone. Bye-bye.